Welcome, everyone. Thank you for joining us for today's webinar, Overview of PHA and LOPA, presented by Nathan Knuckle. BakerRisk has decades of experience completing incident investigations, loss prevention studies, testing and research, and risk management services. During this webinar, Nathan will present high-level introductory material regarding process hazard analysis, PHA, and layers of protection analysis, LOPA, and you will gain general knowledge of PHA and LOPA applicability to existing processes and capital projects and other best practices. For today's webinar, I want to go over a few housekeeping items. First, we have posted links in the chat to content related to our webinar subject. We invite you to explore BakerRisk's published papers, previous webinars, and BakerRisk Training Center courses. Second, we want to respond to your questions following this webinar. We ask that you type questions into the Q&A box in the Zoom control panel, and our presenter will respond to the questions. Finally, at the close of our webinar today, please provide feedback by responding to our survey. And now for the webinar. BakerRisk presenter Nathan Knuckle has 17 years of industry and consulting experience in the U.S., with a focus in the following areas of process safety: PHA, LOPA, independent protection layer, safeguard validation, management of change, pre-startup safety reviews, self-assessments and compliance audits, facility siting, risk management plans, insurance risk assessments, and determining U.S. OSHA, PSM, EPA, RMP regulation applicability. We are excited to have Nathan present this afternoon.
Excellent. Thank you, Naomi, for the introduction, and thank you, everybody, for joining today. The objectives of today's webinar is to provide a crash course into PHA, or process hazard analysis, and layer protection analysis, or LOPA. So we'll be specifically speaking to what is PHA, what is LOPA, what are the requirements and best practices with both, and then high-level philosophy and methodologies with PHA and LOPA. So without further ado, let's jump in. So we'll first start with PHA. So what is PHA? Well, PHA is a tool that's used to identify and describe hazardous scenarios or events that may result in undesirable consequences. PHAs are typically performed to comply with regulations. So if you're in the United States, there's the OSHA, PSM, and EPA, RMP regulations that require PHAs, and other regions as well also have regulations in this space. And the other reason is to ensure that your hazards are being managed appropriately. PHAs can be performed at multiple stages of a project. For example, when you have a conceptual design, or even as that project progresses to detailed engineering, a PHA can and should be performed. But then also, if you have an existing process, you can perform PHA throughout that facility's life cycle. So during routine operation, or even at the end of the life cycle of that facility when you may be decommissioning it. PHAs should be periodically revalidated. Again, in some instances, regulations require it. So if you're in the US, it's a 5-year revalidation requirement. So it's definitely a best practice as well. So just to kind of level set using some general PHA definitions. So as we move through the presentation, we will refer to hazard, and hazard is a potential source of harm. So it's the inherent physical or chemical characteristics that have the potential for causing harm. Typically PHAs always look at impacts to people, so safety, but they also can extend to the property or the environment as well. Hazard identification. So it's the process of pinpointing material, system, process, and plant characteristics that can present or produce, an undesirable consequence. through the occurrence of an accident. And lastly, hazard review. So it's the analysis of hazardous scenarios that have been identified with a process or activity. And the hazard review typically involves using qualitative techniques to, identify consequence and potential weaknesses in the design of the facility. So yeah, those are a few definitions that I think will be helpful. As you're performing PHAs, some considerations to make. The basic scope of any PHA includes the following, but is not limited to. So, evaluation of human factors, evaluation of spacing and layout of your facility, sometimes referred to as facility siting. Considering, inherently safer designs for your operations. Identifying hazards and their associated causes, assessment or identification of applicable design codes, standards and practices, sometimes referred to as REGA-GAP, an evaluation of hazardous events resulting from various failures, equipment failures, human error, process deviations or upsets, etc. PHA also includes risk ranking and comparison to corporate risk criteria. And then lastly, generation of recommendations for risk reduction or consequence reduction as well. So at BakerRisk, we've broken up the PHA process into 5 core steps. So the first one is identify what could go wrong. So looking at your process, where could I have equipment failures? Where could I have human error? Where could my process experience a deviation or upset? And then also, consideration of external events like earthquakes, hurricanes, etc. The next step is, once you've identified what can go wrong, assess the potential consequences for each of those scenarios. So, you may be considering consequences in light of personal harm or safety. As you assess your process, you may have things such as fire or explosions, toxic releases that you have to assess and determine the consequence. And depending on your company, you may also evaluate, impacts to the environment, business interruption or property damage, and potential implications or impacts on a regulatory basis. The third step is identifying safeguards. So for those scenarios, what safeguards do you have in place? They may be preventative, meaning they prevent the loss of containment and hazard altogether. They may be protective or mitigative, and they reduce the likelihood or severity after the loss of containment happens. Or they may be, a combination of both, but are administrative in nature, meaning, it requires human input for the safeguard to work. Step 4, evaluate the likelihood of the event occurring, assuming your safeguards work. As we'll talk later in the presentation, this can be qualitative, semi-quantitative, or fully quantitative. And lastly, after you've assessed your likelihood and your consequence, the team would make recommendations as needed to improve safety, manage risk, etc. So of the 5 steps, we'll go into a little more detail on a few of them. So as you may recall, the first step was identify what could go wrong. Typically, PHA lingo is, identifying causes. So you'll hear the word cause quite frequently, but essentially cause is a reason why an effect may occur. It's sometimes referred to as an initiating event or initiating cause. And I think an example might be the best way to kind of further illustrate this. So let's say you have a chemical process that uses caustic as a feed to a scrubber system. And one of the potential causes for this caustic system may be you lose circulation of caustic. So, what could go wrong, what are some of the causes that could result in loss of circulation of caustic. It could be that you have a mechanical failure associated with your caustic pump, which results it tripping off. You could have a flow controller on your caustic system, and that control loop fails and results in the flow control valve closing. It could be external disruption, so either humid or nature that may impact the ability of the process to deliver caustic. It could be an unanticipated process state, so perhaps you've got crystallization going on in your caustic and it's caused pluggage. Or another common one is the potential for human error. So, inadvertently closing a valve in the caustic system could result in losing circulation of caustic. So, this kind of just illustrates that, you identify something that could go wrong, and then you look at all the possible ways in which that could occur. So once you identify what can go wrong, what you want to do is assess the potential consequence. So how bad can it be? It's very important for the PHA team to understand the inherent and extrinsic hazards of your process so that you can fully assess the scenario and the potential consequences. Process hazards may come from the inherent chemical properties. It could be potential kinetic, subatomic, or electrical energy associated with a system that could create a consequence. Kind of zoning in on chemical energy. Your process based on the chemicals used may exhibit, flammable, it may be a flammable material. So, as you're going through and identifying scenarios and the associated consequence, it's very likely that your consequence may involve a fire or an explosion. Similarly, if you're working with combustible materials such as a combustible dust, your consequence will likely consider and include the potential for dust explosions. If you have thermally sensitive materials, they may experience decomposition if exposed to extreme temperatures. If your process chemicals involve polymerizing or are susceptible to polymerization, you definitely want to make sure that you consider runaway reaction and the potential consequences of that occurring. Perhaps you have shock sensitive materials that may result in detonation. Or another example, again, this list isn't all inclusive, but gives you a flavor for the types of hazards that you might be evaluating in your PHA. So if you have a material that's pyrophoric, if air somehow gets into your system, you might experience ignition of that process. So you want to make sure you assess those hazards as well. To further illustrate consequences, so on this slide, I have an example of criteria for a PHA to define consequences. So on the left-hand side, you can see you have safety, and on the right-hand side of this criteria, you have environmental. And severity or consequence in this example is categorized with a numerical designation of severity 1 through severity 5. Severity 1 being the least severe and severity 5 being the most severe. So in this example, this company is using both an assessment of safety impact and environmental. So as the team, identifies the consequence, they want to make sure that they, summarize it well in the PHA study, such that an individual that comes and looks at the study a year or two down the road, or perhaps it's the team that revalidates 5 years later, they really understand what the thought process was and how that consequence was determined. So it's important for the PHA team to be as descriptive as possible An example here is a team had summarized the consequences: excess flow into tank TXX122, excuse me, leading to overpressurization of the tank and tank rupture with the potential for multiple fatalities. So they definitely go through the process of the steps to the resulting consequence. So you definitely want to make sure that you're very detailed. One key, I guess, philosophy to keep in mind is when you're defining the consequence in the PHA, you basically assume that your safeguards do not work. So that's a very important nuance for the PHA team to remember, is assume when you develop your consequence, your safeguards aren't functioning. Jumping into methodologies. So, there's many methodologies. We'll go over a few today. We won't go over all of them. One of them is what we call hazard. So hazard identification studies. These typically are done when you're in the design stage. And usually you have a conceptual design, but not a detailed design. The hazard aims to identify, your intrinsic and extrinsic hazards and their possible causes. And the outcome of the hazard helps, the project team and PHA in selection of, equipment, your design specifications, and your operating and maintenance, philosophies, strategies, etc. Another common one is what-if analysis. So what-if analysis is essentially a brainstorming approach. It's important that your team is knowledgeable in the process, which is really true for any of your PHAs. You want to have personnel that have working knowledge of the process hazards and how the process works. But in the what-if approach, basically your team will divide your study into nodes. Basically that means breaking your process into different sections and then evaluate each section by section. And the team basically brainstorms and postulates failures and scenarios by asking what if. So for instance, what if this valve fails closed? What if this valve fails open? So they'll generate a list of, what if questions, and then they'll go through each of them individually and identify the potential consequences for each scenario. With that, then they would identify safeguards that would, prevent or mitigate the consequence, and then as needed, develop recommendations. Another common one is hazard and operability studies, or HAZOP. HAZOP's very structured. It's used pretty commonly in industry. In fact, the terms PHA and HAZOP are typically used interchangeably. And HAZOP's best applied when you're in the project phase where you're completing detailed design. And HAZOP is typically used for existing facilities that have fairly complex operations. So the core principle of the HAZOP methodology is to assess hazards using a series of guide words and deviations. So the guide word deviation pairs are applied to each node, leading to a very thorough and structured analysis. So for example, let's choose the guide word flow. So then applying the guide word deviation pair, we would assess, okay, what happens if we have more flow or excess flow? What if we have less flow? What happens if we have reverse flow? What if we have no or, basically no flow? So it's a very structured approach to make sure all of your guide words and deviations are assessed. So those were a few of the PHA methodologies that are used in PHAs. For all PHAs, after you identify the cause and the consequence, they'll go through and evaluate likelihood. So on the left-hand side of the slide, you see an example, what we call risk matrix. So on your y-axis, you have severity or consequence. And then on the x-axis, you have likelihood or frequency. So, similar to the criteria shared before on consequence, we have descriptions for each of the, likelihood groupings. So we've got numerical designation 1 through 5 for likelihood, where 5 is the most frequent and 1 is the least frequent. So, once you identify your initiating event, your consequence, and then safeguards, you can assess what the overall scenario likelihood is anticipated to be. On this risk matrix, you can see there's different colors and different numbers. These correspond to different risk regions. So for example, if you're evaluating a scenario and it has a relatively high severity or high consequence, let's say 5 is multiple fatalities, and let's say the event occurs very frequently, even with your safeguards. So in L5, you can see you're in this red 4 region, which is the highest risk region on this risk matrix. So that team is likely going to want to, put together some recommendations to further reduce risk so that you can get down into the, yellow 2 or green 1 risk regions. And this is just an example, depending on your company's criteria and requirements, that might look a little different. So yeah, like in the example on the previous slide, if you're in the risk region 4, the team will likely want to identify recommendations. And keep in mind that your recommendation should highlight a concern and provide a suggested solution. Recommendations are not instructions for your design or engineering team. The recommendation should be written in such a manner that anyone reading it, meaning just the recommendation alone, they should understand what is being suggested and why. It's important to reference any kind of pertinent documents or information that would help the person reading or receiving that PHA recommendation to implement. When you're suggesting a solution, it's best to provide the best option as agreed by the PHA team, and be careful in your selection of recommendations. It shouldn't be a wish list. It should really be providing improvements to your safety and risk reduction to your facility. I have a few examples here of recommendations. As you can see, as you move down the slide, they're more detailed in nature. So while the first one is well, it's not really a good recommendation at all, because it just says review the need for high level to prevent loss of process containment. As you step through, you can see there's additional information. So in the second one, the team is actually providing what they see as the best solution to mitigate the hazard. So they actually suggest interlocking the pump at 90% level. And the best recommendation here is saying, hey, review technology options, because it's not necessarily the responsibility of the PHA team to do all of the design details. It's more or less to highlight the concern and why it's of importance. And if they already know that, hey, this type of level switch technology works and is okay, it's okay to specify that. But in all situations, the team might not have that information. So be as detailed as possible in your recommendations. So moving on to the subject of LOPA. What is LOPA? So LOPA is a risk assessment methodology for assessing hazardous scenarios. where one or more safeguards may or may not already be in place. And it's a tool used to determine if you have adequate, protection. So is your risk tolerable? So when should you do LOPA and why? So really, this question of when is dependent upon your specific company's requirements. But what we've seen is a lot of times companies will have corporate guidance that says, if your scenario reaches a specific severity or consequence threshold, you need to do LOPA. Or there's some instances where companies say, okay, when your PHA identifies the need for a safety instrumented system, then you would need to do LOPA, and that would be helpful in determining the safety integrity level needed for that safety instrumented system. Or some clients have said in their corporate standard on demand, so whenever it's desired by the PHA team to better understand risk. So what are the benefits of LOPA? So why do LOPA? LOPA is a simple structured method. It typically gives consistent analysis results. It provides guidance or basis for evaluating failure rates for people and equipment. And it provides a direct quantifiable relationship between tolerable and anticipated risk. So, when you're assessing risk, you can do LOPA, which is a semi-quantitative approach. You can also do quantitative risk assessment or QRA. One of the advantages of LOPA is it's less time intensive than a full-blown QRA. It requires, less inputs, less time. LOPA also provides a consistent and simplified framework for making risk judgments. So as you move through scenario by scenario, you're being consistent and your results are consistent. LOPA is more defensible than, qualitative judgments. And LOPA provides a basis for clear and functional specifications for IPLs. So, how robust does your protection layer need to be? And it also provides a way to compare risk in your facility or across your facilities. Some disadvantages to LOPA. LOPA is not intended for scenario identification. That's really what your PHA should be doing, is identifying the scenarios. And then you take those scenarios identified in PHA and then, per your company requirements, take those to the LOPA process. In some instances, the rules and philosophy with LOPA may be overly conservative, or, honestly, it may not be conservative if your process, has failure rates that are higher due to the service or nature of your process. That could also not, that could be underestimated. LOPA can be very time consuming. It definitely takes more time because you're digging into more detail in your initiating events, your safeguards, and ascribing, probability of failure on demand, which we'll talk about in a minute. So while LOPA is very time consuming, it's best used for your more complex scenarios. And then this kind of was mentioned earlier, inconsistencies and failure data. So, the values provided by LOPA are general and broad for industry. And of course, you want to be, considering what your facility or process actually experiences as you go into LOPA. So as a part of LOPA, as mentioned, your scenario identification occurs in the PHA. Really the first step for the LOPA process is to quantify your initiating event. So, your PHA identified the types of PHA initiating events, and now with LOPA, you're wanting to put a number to how frequently that initiating event occurs. So, we kind of talked through this. There's different types of initiating events. You've got instrument malfunction, human error, extreme weather event, etc. So the LOPA methodology provides general initiating event frequencies that you can apply to each failure type. So on this slide, we're depicting frequency on your risk matrix. We kind of talked about it in earlier slides, but in this example, the team identified the initiating event frequency is between 10 to -2 and 10 to -3, so between once every 10 years and up to once per year. So perhaps this is a human error frequency. And yeah, it's just basically showing that, based on your initiating event, you can assign initiating event frequency. So moving on from initiating events, there's a concept of enabling conditions. So enabling or conditional modifiers is an event or condition that makes possible another event. So enabling conditions are not initiating events and not directly the cause of the scenario, but must be present or active in order for the scenario to progress to the defined consequence. So some examples of an enabling event, ignition in the case of a flammable cloud. So in order for you to have, a vapor cloud explosion, you have to have ignition. So your ignition is an enabling event. Overfilling, you can only overfill a tank when you're actually filling it. So for example, if you're only filling the tank 10 times a year, then the risk of overfilling is a very small fraction of time where this hazard exists. Conditional events. So for example, if you have a toxic release, one of the conditions is, the wind has to be blowing towards the people, leading to their injuries. There's also conditional, like people have to be present in the area when the event happens. So sometimes some clients apply conditional modifiers as well. Enabling conditions are not protective layers, but they're probabilities that can be applied to the LOPA scenario. So once you've, quantified your initiating event frequency, identified any kind of enabling conditions, the next step is to, assess your independent protection layers. So what is an independent protection layer? It's a device, system, or human action which meets core attributes defined by LOPA as providing the necessary level of rigor and is capable of preventing an initiating event from propagating to a hazardous event. So on this slide, we've listed out several of the IPL core attributes. So in its name, independent protection layer, it's very important that as you identify safeguards, that failure of one safeguard does not result in failure of your other safeguards. So they need to have independence. As mentioned in the definition, from a functionality perspective, they have to be capable of preventing the initiating event from propagating. Integrity and reliability. So, you want to make sure that you have the appropriate rigor or robustness of safeguard and that it's, ready and present and available when it's needed. Also auditability, so you want to be able to, from time to time check to make sure that your IPLs are functioning as intended. If it's a control system or safety instrumented function, you want to make sure that, no one can go in and alter the functionality or disable the safeguard. And then also you want to make sure that, throughout the life cycle of your facility, you're managing change and making sure that, any impacts to your IPLs are identified and managed accordingly. So all IPLs are safeguards, but not all safeguards are independent protection layers. This slide is just depicting, the various levels of layers of protection that you can have in your LOPA. So, here's your process as you move out. There's 6 different prevention layers. And then as you move further out, you've got 3 mitigation layers. So the prevention layers work to prevent, the initial primary loss of containment, whereas mitigative layers, they're safeguards that are present that, are there to minimize impact after loss of containment. So general, philosophy around this is you typically want to try to identify your safeguards and independent protection layers and in the inner region, and then as needed, move out. Mitigated event frequency. So we talked about initiating events. We talked about enabling conditions. We also talked about IPLs. So IPLs have specified what we call probability of failure on demand, PFDs. And basically, that's kind of defining how robust your safeguard is. So for instance, an operator response to an alarm would be given a 0.1 PFD, which means 1 in 10 years is the probability of failure on demand. Basically, after doing your initiating event, your enabling conditions, you want to give values for each of your independent protection layers. Once you define your robustness or your risk reduction credit for each safeguard, you can assess mitigated event frequency. And mitigated event frequency is a product of the frequency of the initiating event. It's multiplied by the probability of failure of all protection layers, and also includes any of those enabling modifiers that we discussed. So mitigated event frequency is the overall likelihood that the undesired event is going to happen with all of your safeguards and with any type of enabling modifiers identified. So here, we started with initiating event that was quantified to be 10 to the minus 2 to 10 to the minus 3. As the team, progresses, identifying IPLs, identifying their risk reduction credits, and maybe even, identifying enabling conditions. In this example, you can see they moved down 2 orders of magnitude to a likelihood of 3. So puts them in the yellow region. So that kind of just illustrates, what's going on as you're identifying the probabilities, frequencies, and what that looks like on your risk matrix. So we covered a lot of material. Again, this is truly a crash course. On the screen, we've got several different CCPS references that are very helpful for you as you're doing LOPA in terms of methodology, defining initiating events and protective layers, and then also, going into more detail about enabling conditions and conditional modifiers for your LOPA. So in conclusion, what is PHA? It's a tool that's used to describe and identify hazards, which could result in undesirable consequences. How is a PHA conducted? It's conducted in a team. It's a team effort. From a workflow perspective, it's identifying those hazardous events along with their causes, identifying any safeguards that may prevent or mitigate the consequences. PHA methodologies, there's several. We only covered a few. So pick the methodology that best fits your situation. So, if it's in the project phase, if it's conceptual or detailed design, or maybe you're a running facility, pick what makes sense for your need. And then lastly, LOPA. LOPA is a semi-quantitative risk assessment that's done after PHA. PHA identifies the scenarios and causes, and LOPA takes those and quantifies them to assess if your risk is tolerable or if further risk reduction is needed. So with that, we'll open it up to any questions.
Perfect. Thank you so much, Nathan, for your presentation and all that great information. I'm going to go ahead and ask some of the questions that did come up during the presentation. And just as a reminder to our attendees that if you have any other questions, we ask that you type them into the Q&A box in your control panel. So one of the questions that came up, Nathan, is how have you seen others perform LOPA studies? And is it common for the PHA team to also perform the LOPA assessment?
Yeah, thanks, Naomi. That's a great question. It depends. So I've seen different clients do different things. So I've seen lots of clients couple their PHA and LOPA work processes together. So, as the PHA team goes through and works through an entire node, they identify all of the, you know, um, causes and consequences. Once that's complete, then that team will take all of those scenarios to LOPA and evaluate those in the same session. I've also seen others in industry have a separate work process where the PHA team and the LOPA team are typically, separate meetings. They may include some of the same people,
Mhm.
but they're separate events altogether.
Gotcha.
And yeah, and honestly, like it just depends on what works best for you and your team, and what's most efficient.
Okay. Another question that came up, or what do you see is a common trigger for PHA scenarios to be evaluated with LOPA?
Yeah. So again, I've seen different things. I think what I see the most in industry has been, a company or corporate policy that says at certain thresholds of severity or consequence, anything at that level or higher would require LOPA. I'd say that's probably the most common.
Great. And then I'm going to ask one more question because we're running out of time for the webinar. So what PHA methodology do you recommend for PHA studies?
Yeah, it's a good one. Again, I'm going to caveat my response on it depends. So, as discussed, you may be performing PHAs throughout, different stages of the life cycle. So, if you're doing a project and you have a very conceptual high-level design, you're likely wanting to use a methodology such as hazard. So you're identifying your basic hazards. If you have a very simple process that's already existing, you might not need the robustness of a hazard. Maybe a what if checklist approach would really deliver all that you need based
Mhm.
on the simplicity of the hazards. And if you have an existing process that's very complex and has lots of hazards, I would suggest using the hazard methodology, as it's very structured and helps the team make sure that all potential deviations are considered throughout the study.
Gotcha. So, Nathan, again, appreciate your time today. And it looks like we've covered only a few of the questions that were asked today. So to our attendees, if you have additional questions, go ahead and type those into the Q&A box and Nathan will answer those questions and we'll send that either as a recording or just typed answers with the links to this recorded webinar, slides from his presentation, and then those answered questions together. So thank you, Nathan.
Yeah, thank you. Thank you, everybody.
And as a final reminder, today's webinar is going to be posted again, like as I stated earlier, to our website. And once that recording is available, you'll receive an email from BakerRisk with those links. So again, we ask that you complete the survey at the conclusion of this webinar. And thanks again for joining us today, everyone. Have a great day.